Hello, welcome to the Ankara Yıldırım Beyazıt University Soil Mechanics Laboratory. This video will demonstrate how to conduct a plastic limit test. The relevant ASTM standard is ASTM D 4318-05, Liquid Limit, Plastic Limit, and Plasticity Index of Soils. The plastic limit is one of 3 Atterberg limit tests and is always conducted together with the liquid limit test to determine the plasticity index of a given soil. The determination of the liquid limit of a soil was shown in a previous video. The equipment needed to run the plasticity test are a porcelain evaporating dish, a spatula, a plastic squeeze bottle, a balance sensitive up to 0.01 grams, moisture cans with lids, a ground glass plate, and a 3 mm rod used as a reference for the thread thickness. In order to prepare the soil, you should put about 20 grams of air-dry soil sample passed through the number 40 sieve into a porcelain evaporating dish. You need to add water using a squeeze bottle and mix it thoroughly until you obtain a thick paste. You may place the soil in a container with a lid and let it stand for some time while you conduct the liquid limit test for the same soil. During this period, the clay particles will have time to fully hydrate and form their diffuse double layers. We have already hydrated a clay specimen, as you can see here. Determine the mass. You also need to determine the mass of 2 moisture cans. To start the test, prepare 2 ellipsoidal-shaped soil clumps by hand. Roll one of the soil masses between your palm and the glass plate. The correct rate is about 80 strokes per minute. Note that 1 stroke is equal to 1 complete backward and 1 complete forward motion. Continue rolling until the thread is about 3.2 millimeters thick. You can compare the thickness to the 3 millimeter metal rod. Break the thread into pieces and combine it into a ball by squeezing in your hand. Repeat the rolling, thread making, and recombining process over and over again until the threads just crumble when they reach 3.18 millimeter diameter thickness. As you roll the soil clump with your fingers, it will continue to dry the soil. The objective is to have the soil reach 3 millimeter thread size just as the water content reduces to its plastic limit. At this point, collect the crumbled pieces into a moisture can and cover with the lid. Continue making threads that just crumble at a thickness of 3 millimeters and add them to the moisture can. You should make enough threads that the moisture content determination is sufficiently accurate. Take the second ellipsoidal-shaped soil clump and repeat the same process. Fill the second moisture can with enough soil threads to give you an accurate moisture content. Weigh both moisture cans with damp soil threads and place them in the oven to dry overnight. Record the weights in your data sheet. Calculations. Determine the moisture content of the soil threads as usual. The weight of water lost is the difference between the weight of the can with the moist threads and its weight with completely dry threads. The dry weight of the soil is the difference between the weight of the can with dry threads and its tare weight. The water content is the weight of water lost divided by the weight of soil, the dry weight of soil. The plasticity index is the difference between the liquid limit and the plastic limit. The plasticity index may also be used to determine the activity of the clay if the percentage of clay has been determined using a hydrometer test. In other words, if the percentage of soil with sizes smaller than 2 microns is known, the activity of the clay can be determined.